All right, so we are still in 1.4 and we are looking to finish up this application problem. So this application problem says that we have these data points. We're going to use the two data points that were given, the XY ordered pairs, to create a linear function that models this average global temperature for an atmospheric carbon dioxide concentration of X parts per million. So we want to take this and we're going to write this in that slope-intercept form. So the first thing we have to do is we have to find the slope. And so what we did first is we labeled the points x1, y1 and x2, y2. And then we're going to take them and we put it into the slope formula. And now, instead of doing this by hand, I'm going to grab the calculator. Now, I would like you to follow along on this calculator. And when you're doing this, you make sure you surround this numerator. If you want to do it in one step, which is what I suggest to do, you surround the numerator and the denominator with parentheses so that the calculator does the subtraction before it divides and does this subtraction before it divides that number. So I'm going to write it like this. So here's my numerator, and then I'm going to hit divide by, and then put the denominator in parentheses also. If you do not include the parentheses, oops, I hit the wrong button here. Let me change that. If you do not include the parentheses, then the calculator is only going to divide the two numbers in the center, and your answer will be incorrect. What's nice about this calculator is that you can, just like I just noticed an error there, I can look back at it and I can see what I entered. And I noticed I hit the button next to the 4 and not the 4. And so I was able to arrow back the left and right arrows to enter the correct number. And so I'll hit enter, and then this is the value I get. So let me write that value on my screen. So I end up with M is equal to 0.016216216. And so I have this repeating decimal. The problem said to round the slope to 3 decimal places. So 1, 2, 3 decimal places. So I want to round it to this value. I look 1 over, and if that number is 5 or more, I round this number with the arrow up. If this number to the right is less than 5, I keep this number the same. So I'm going to round this to 0.016. So the slope here is 0.016. And that's going to go in place of the M. Now, I'm going to find what value to put in for B. Now, to find the value to put in for B, I'm going to use this next page to do it. I can use this formula. And I'm going to show you an alternate way to do this too. So this is using the slope-intercept form. To find B, you take the slope-intercept form and you solve it for B. So that means get everything else on the other side. And so I'm going to label these x1, y1, and I'm going to put one of the points in for x and y. It doesn't matter which point I put in. So one of the points was, I'm going to just write the points right here so I have them to reference. One of the points was right here, so I'm just going to use this one. It does not matter which one you use, you'll get the same answer either way. The slope I found to be 0.016. Now, really, I should wait to round that to the very end. So I could use, I might have a little bit of rounding error if I use it rounded. I'm just going to use it like that. And let's put, so I'm going to say 57.04 minus, now I have this slope as a previous answer, so let's just use the previous answer by hitting, if you hit second and then the negative sign, it pulls the previous answer down so that I don't have to type that out. And like I said, it's best to use it unrounded. So I end up with this value, and I'm going to write that down here. Now, if you use 0.016, you're going to see that the number that you get is slightly different, and that's only because of rounding. So I get 51.89945946, but rounding to 3 decimal places, it would look like this. So this is my B. And so now I'm going to take my equation, and in place of the slope, I'm going to put in 0.016, and then I'll say x plus 51.899. This is my answer. And I'm just going to use what they told me. It was a function, and they used this f of x. So this was my answer using the using the slope-intercept form. Now, I can do this same problem, and I can use the point-slope form. The point-slope form, remember from video 1, is y minus y1 is equal to m times x minus x1. So what I'm going to do here is I'm going to take one of the points, and I'm going to plug in the y and the x value in these two places. And then I'm going to take the slope, and I'm going to plug it in for m here. And again, I'm going to use the unrounded slope, but for ease of writing, I will just put the rounded value there. So putting in y1, putting in the slope, and then putting in x1. So I'm starting from the beginning. I don't have the b yet, so I'm just going to do it like this. And now it's just a matter of simplifying. So I'm going to first distribute this. And again, the rounding of this number here is going to cause a slight rounding error. You'll see that our answer will be slightly different than what we got here. I have to take the 0.016 and I have to distribute it to the 317. So I'll do that using the calculator. So I'm going to multiply, and let's see what we get, 5.072. And that's negative because this value is negative. And then all I have to do is solve this for y. So add 57.04 to both sides, and you'll get your answer, which is y is equal to 0.016x. And then let's see what I get over here. Let's grab the calculator. So that would be negative 5.072. I'm using this negative sign here, plus 57.04. Hit enter, and I get 51.968. And so notice how my answer is just slightly off, but it's the same thing. It's just a rounding error. So, and again, I'm going to put f of x. So this is using the point slope form. And this was using the slope intercept. And probably if I use the 0.016, you'd see that these numbers are even closer together than they are here. And so that is the equation, or the linear function, that will model the average global temperature. So if you put the carbon dioxide concentration in for X, you will get the average global temperature for your output. All right, and that is the end of section 1.5.